All right, as promised, I wanted to give you a video on your access control lists, some demonstrations. There'll be a couple of videos in this one here because I want to make sure we cover what an ACL is, purpose of the ACL, concepts of the ACL. We're going to look at wildcard masks, the guidelines for creating an ACL. Then we'll move into another module. We're actually going to create some access control lists, some standard access control lists. We're going to create some named ACLs, and we're gonna make some yeah, some extended, some standard, and some named ACLs, and then we're gonna show you how to apply them to the interfaces, and so you can see how they block traffic. Now, so basically, what is an ACL? Well, routers make their decisions based on information in the packet header. So traffic entering a router interface is routed solely based on the information within the routing table. Now, the router compares the destination IP address with routes in the routing table to then find the best match and then forwards the packet based on the best match route. The same process can be used to filter traffic using an access control list or an ACL. Now, an ACL is a series of iOS commands that are used to filter packets based on the information that are found in the packet header. Now, by default, a router does not have any ACLs configured. However, when an ACL is applied to an interface, the router performs the additional task of evaluating all network packets as they pass through the interface to determine if it can forward that packet. Now, an ACL uses a sequential list of permit or deny statements, known as what we call ACEs or access control entries. Now, note that ACEs are also commonly called ACL statements. Now, while network traffic passes through an interface configured with an ACL, the router then compares the information within the packet against the entry in sequential order to determine if the packet matches one of the entries. The process is called packet filtering. So here's really how it works. The task would be then to limit the network traffic to increase the network performance. So for an example here, corporate policy prohibits video traffic on the network to reduce the network load. Then a policy then can be enforced using ACLs to block the video traffic. Perhaps we want to provide traffic flow control. An example of that would be a corporate policy requires that the routing protocol traffic be limited to certain links only. The policy can then be implemented using ACLs to restrict the delivery of routing updates to only those that come from a known source. Maybe we want to provide a basic level of security for network access. Corporate policy demands that access to the human resources network be restricted to authorized users only. A policy then can be enforced using ACLs to limit access to specified resources. We can filter traffic by traffic type. Corporate policy, for example, requires that email traffic be permitted into a traffic, but that telnet access be denied. So a policy would then be implemented using ACLs to filter traffic by type. Screen hosts to permit or deny access to network services. So, for example, a corporate policy requires that access to some file types like FTP or FTP be limited to specific user groups. We could then just create a policy and implement it using ACLs to filter user access to services, or maybe provide services or provide priority to certain classes of network traffic. So, for example, a corporate traffic specifies that voice traffic be forwarded as fast as possible to avoid any interruption. So we would create a policy that can be implemented using ACLs and quality of services to identify voice traffic and process it immediately. So if we're going to do our packet filtering, Packet filtering controls access to a network by analyzing the incoming and outgoing packets and then forwarding them or discarding them based on any given criteria. Packet filtering can occur at layer 3 or at layer 4, so by IP address or by the protocols that we're looking at. We have two types of ACLs that we want to talk about right now, and they are standard ACLs. Now, standard ACLs can only filter at layer 3 using the source IPv4 address only, where an extended ACL filters at layer 3 using the source and or destination IPv4 addresses. They can also filter at layer 4 using the TCP or UDP ports and any other optional information for finer control. ACLs define a set of rules that give added control for packets that enter inbound interfaces, packets that relay through the router, and that exit the outbound interfaces of a router. Now, note that ACLs do not act on packets that originate from the router itself. And inbound ACL filters packets before they're routed to the outbound interface. And inbound ACL is efficient because it saves the overhead of routing lookups if the packet is then discarded. So if the packet is permitted by the ACL, it is then processed for routing. Inbound ACLs are best used to filter packets when the network attached to an inbound interface is the only source of packets that need to be examined. An outbound ACL filters packets after being routed, regardless of the inbound interface. Incoming packets are routed to the outbound interface and then they're processed through the outbound ACL. Outbound ACLs are best used when the same filter will be applied to packets coming from multiple inbound interfaces before exiting the same outbound interface. When ACL is applied to an interface, it follows a specific operating procedure. So for example, here are the operational steps used when traffic has entered a router interface with an inbound standard IPv4 ACL being configured. 1, the router will extract the source IPv4 address from the packet header. Then the router starts at the top of the ACL, compares the source address to each access control entry in a sequential order, basically top to bottom. When a match is made, the router then carries out the instruction, either permitting or denying the packet, and the remaining ACEs in the ACL will then, if any, are not analyzed. So you have to make sure that when you are building your ACL, that if you're going to deny a packet but you want to allow another type of packet, okay, you have to make sure that you have your deny statement put in the appropriate spot, or vice versa. Because if you wanted to deny someone but allow them, you'll never get to that allow statement if you already denied them, because it literally stops reading it. So if you were to put your access control as permit, 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 deny, permit, permit in, say, a notepad file, and then as soon as you hit one of those criteria, once you hit a match, it'll stop reading the notepad file, and you might not get the result that you wanted. If the source IPv4 address does not match any of the ACEs in the ACL, the packet will automatically be discarded. So what you want to understand is at the end, whether you write it in or not, we're always going to have an implicit deny statement. The last ACE statement of an ACL is always implicit deny. It blocks all traffic. So by default, this statement is automatically applied at the end, even though it is hidden and not displayed in any of your configurations. It is important to note that an ACL must have at least one permit statement, otherwise all traffic will be denied. So now I want to run you through a demonstration of a packet tracer where we're going to show you how the access control list would actually work. It's just a demo, and I'll post a demo up on the site for us to look at as well. Okay, so here we have a basic network set up, and what we want to do with this, plain and simple, okay, is we want to verify local connectivity and then test the access control list. We want to remove the access control list and then repeat the test. Okay, so basically right now everything's already been pretty much set up, where R1 has 3 interfaces attached to it, G0, G01, and S00. So here we are. We have 192.168.10.0 network, so this is 10.1. We have the 11 network, so this is 11.1. And then we also have the S000 here, which is 10.1.1.1 with a /30. R2 sitting up right here. Okay. R2 has 2 serial ports. We have 10.1.1.2, so it's on the same network as this guy here. 10.10.1.5 is right here. He's going to be talking to 10.10.1.6 right here. These two networks here coming off are 10.192.168.30.1 and 192.168.31.1 network. The PCs 1, 2, and 3 are on their appropriate networks as well. And so the first thing we want to do is we want to make sure that we can ping devices on the local network to verify their connectivity. So from the command prompt here on PC1, I want to be able to ping the address of PC2. Okay. With that being said, PC1's address is 192.168.10.10 and PC2 is 10.11. So I want to ping 192.168.10.11. Oh, you actually got to have your numlock on. Ping. Okay. And as you can see, I can ping from PC1 to PC2. Okay. Now I want to make sure that PC1 can ping PC3. Now understand, PC1 did not have to go up to the router to ping PC2. Now I'm going to go and ping, I have to go through my router and ping PC3, which is 192.168.30.12. Okay. As you can see, I cannot ping 30.12, which is PC3. Okay. Now from the command, I want to see if I can ping PC4, which is 192.168.30. I'm sorry. That was PC4. I'm sorry. I couldn't ping PC4. Now I'm going to see if I can ping 192.168.11.10, which is PC3. And as you can see, I can ping 3. Okay. So now what we want to do is we want to take a look at router 1 and find out, okay, based on the configuration for router 1, right? We want to find out. So PC1 to PC4 failed. From the command prompt to PC1, we want to ping our DNS server, which is over here. Okay, the DNS server is 192.168.31.12. Once again, destination host is unreachable. So I cannot ping these two networks on this side. Okay, I can PC3 if I remember correctly, let's take a look. PC3 was 192.11.10. And we could ping that one. So we can ping everybody on this side, on these two networks. I cannot ping anybody over on these networks over here. Okay. So now what we want to do is we want to take a look. Okay. We're assuming that the pings failed because there's an access controller. So let's take a look. Okay. So we go into simulation mode and bring this out. Bring our command prompt back up. And let's ping the 31.12 address, which is our DNS server. Okay. We see our packets going through our destinations. And you'll see our packet getting blocked and then sending our responses back. So you can see our packets in this instance here, our ping packets, are getting stopped at R1. Okay, with our host unreachable. So we never really made it past R1 in that one there. So if we were to take a look, okay, we go to R1 and go to our command line interface here. Right. Now we just want to do a typical show command. All right, so we want to do a show access lists. Okay, so we can do a show run and show access commands to view the currently configured ACLs. To quickly view the current ACLs, we would just do a show access dash lists. And you can see we have one called access list 11. Now, what we have here is it breaks it down into segments. So by 10. So we have 10. The first statement says is deny. I want to deny the 10.network, which is this network right here. Okay. PC1 and PC2 are the 10.network. Okay. I want to deny them. You'll notice that I have an inverted subnet mask, and we'll talk about that in a little bit. 0.0.0.25. Okay. So we're just going to deny. Basically, all we're saying is we are denying this guy to go through that router at all. That the 10.network cannot go to R2, cannot go to R3. It is stopped right there at the end of R1. Everybody else, if you're not on a 10 network, okay, everybody else, you're allowed to go in, right? So now what we're going to do here is we are going to remove, okay, the ACL. So we did our show access list, right? And for an ACL to impact router information, this is important first. Okay, for an ACL to impact router information or router operation, it has to be applied to an interface in a specific direction. So in this scenario, the ACL is used to filter traffic on an existing interface. Therefore, all traffic leaving the specified interface on R1 will be inspected against access list number 11. Now, although you can view IP information in the show IP interface command, it may be more efficient in some situations to simply do a show run command to obtain a complete list of interfaces that the ACL may be applied to, and a list of the ACLs that are configured using this following command here. So take a look. If we do a show run, then we use the pipe symbol. That's a shift. It's right above the enter key. Okay. And I want to include interfaces. And access. Okay, so now you can see, right? So I want to show my interfaces and I want to include the access list, okay? So as you can see, okay, we have interface G00 and G01, okay? And we have interface S00. IP access group 11 out. So what we're saying is, what you want to do when you're applying an access group, an access list onto an interface, put yourself literally inside the router, okay? And think, okay, do I want to send traffic in or do I want to send it out? Okay, so IP access group 11 out. Okay, so because the rule is you can have one access list per interface, per protocol, per direction. So in this case here, on these three interfaces, we have access group 11 going out. Okay, we're not allowed to go that way. We're not, but we are allowed to go this way. So let's take a look here. I was allowed to come in. Let's take a look. So as you can see here, S00, we stopped it from going out. On G01, okay, on G01, I'm allowed to go this way. On G00, there's nothing there. So as you can see, if we were to scroll back up to our command here, we ran the include command, I showed my two interfaces. There's nothing going on there, right? On this guy here, we have the interface and we have the access control list and what direction it was applied. So this is my S00 port right here. We're not allowing the packets from this network right here, the 10.0 network, to leave. I allowed it to go out this one. I did not allow it to go out that one there. So the next thing we want to do, let's see if that's actually happening. We're going to actually remove the access list 11 from the configuration. Now there's a number of different ways that we can do that, okay? So we could go under the S000 interface and remove the access list 11, okay? Now if you remember, whenever we want to remove anything or delete anything on a Cisco router, you want to use the no command, remember? Cisco devices are like small children. You got to keep telling them no. So in this case here, I could go into interface S000, do a no IP access group 11 out. Okay. I can do that in the interface command. So go into config T. Let's go into the interface of S0/0/0. And I'll do a no IP access list 11. It has to be to tell what direction you want to remove it from. All right, didn't like something I typed in there. What? Oh, because it's access group. My bad. When we apply it, we create access list, and when we apply them, they're called access groups. It's a group of commands. Okay, so access list group out. Now, typically in this case here, everything happens automatic, so I should be able, okay, to ping that DNS server now. There we go. Now, I did that without actually removing the access list, but if I want to remove the access list, I would exit back out into global configuration mode, and I would say no access-list 11, and I just removed it. Okay? So that's really right there. That's a demonstration on a basic, simple access list, really. Okay? So now we want to take a look at what that whole inverted subnet mask, or what we call a wildcard mask, actually is. So if we take a look at what a wildcard mask is, okay, so when we looked at the ACL that we originally created, it just said permit 192.168.10.0, the network, and then it did a space and 0.0.0.255. So what that means is we're actually comparing the bit numbers together. Okay, so a wildcard mask, similar to a subnet mask, okay, uses the ANDing process, identifies what bits that we're going to use to make a match. Okay, wildcard mask is similar to a subnet mask, okay, and it does that. Unlike a subnet mask, in which binary 1 is equal to a match and a binary 0 is not a match, in a wildcard mask, it's the reverse. Okay, the opposite then would be true. So wildcard mask use the following rules to match 1s and 0s. Okay, wildcard mask bit of 0, match the corresponding bit value to the address, and a 1 is ignored. So the way I always try to teach this would be to say the 0 is to observe, okay, like an O for observe, and a 1 is ignored, like an I for ignore. So if we were to take a look at it in this table here, you'll see 0.0.0, okay, means I'm matching everything. Match all the octets. It has to be a perfect match, okay? So if it's 192.168.10.1, then it must be a 192.168.10.1. In the second one, you want to match the first 3 octets, okay? So it's 192.168.10, all right? And then after that, you want to match the 2 leftmost bits of that octet. So which means they're going to have to be, it's going to be a higher number there. Anything from a 64 through 128, 192 actually, would have to come into that one there. Right? In the third one there, you see match the first 3 octets, and then you have to match the 4 leftmost bits of that octet, ignoring the last 4 bits of that octet. So anything up to 15 could get through your network. Right? The next one, match the first 3 octets, ignore the 6 most left bits of the octet, and so on. Okay. Now the different kind of wildcard masks that we have. Okay, using wildcard masks will take some practice, and if we were to look at how a wildcard mask is used to filter traffic for one host in one subnet, or maybe even a range of hosts. Okay, so in this example, the wildcard mask is used to match a specific host IPv4 address. So ACL 10 needs an entry that only permits the host with IPv4 192.168.1.1. So now recall that a 0 equals a match and a 1 means ignore. Right? So to match a specific host IPv4 address, you would just use 4 zeros, and everything has to hit it spot on. Okay. But if we wanted to match an IPv4 subnet, okay, just subnet itself, we would use something similar to this. So in this example, the ACL 10 needs an entry that permits all the hosts in the 192.168.1.0 network, similar to the one that we did in our demonstration. Okay. In this case here, the wildcard mask is 0.0.0.255. It'll stipulate that the very first 3 octets have to match exact, but the 4th doesn't even look at. And then if we want to hit a range of addresses, and this is important, especially if you're doing subnetting, and you want to say like this section, these first groups right here, they're allowed to work, but this group over here isn't allowed to work, right? So in that case there, if I want to hit a range, So in this case, ACL 10 needs an entry that permits host 192.168.16.0, okay, 192.168.17.0, and so on. The 192.168.1.31.0 in networks. Now the wildcard mask, it would be 0.015. So if you were to take, now if you were to take a look at it, okay, see we have the 15 right here, okay? If we were to take all those bits, okay, the 1, okay, the 2, the 4, and the 8, okay, and add all these up, okay, the 1, the 2 is 3, the 3 and the 4, okay, we end up with 15, right? Okay. The next number here, okay, the next number here, this is my 32-bit, okay? I'm sorry, this is my 16-bit right here. So 1, 2, 4, and the 8, okay? 1632, okay? So in this case here, what I want to check for is my 32-bit, okay? So I'm matching because I'm allowing the 31 on up to come through. That's what you have to look at there. All right, so in here, the highlighted wildcard mask, okay, of what I want to permit coming in, okay, because the next guy who gets turned on, okay, that I'm ignoring, okay, so I'm ignoring these guys right here up to 31, okay, so this is my 128, my 64, and my 32, okay, so this is 31 on down. These are the guys that I'm ignoring, so I'm allowing up to the 0 or the 16, okay, and the 31 are allowed to come through. Everybody else I ignored. It's a little tricky at times to figure out. So calculating a wildcard mask can be a bit of a struggle, and it can be challenging. But one shortcut method would be to subtract the subnet mask from all 255s. Okay, so let's assume you wanted an ACL to permit access to all users in the 192.168.3 network. So to calculate the wildcard mask, you would do you subtract subnet mask 255.255.255.0 from 255.255.255.255, which would then give you 0.0.0.255. Right? If you wanted an access control entry to permit network access for 14 users in the subnet, so your subnet mask would be 192.168.3.32/28. And in that case there, okay, the solution would give you a wildcard mask of /15. Therefore, the ACE would be 8 access list 10 permit 192.168.1.3.32. Okay, so what we want here is 14 users in the subnet. Okay, so you'd have to, with your subnet mask, the /28 subnet mask, and you want the last 14 users. So your subnet mask would be a /28. You'd be a 255, 255, 255 to 240. And then you would subtract that out from the 255. You would have 0.0.015. Okay. The next one you want to look at would be if you needed to permit only networks 192.168.10 and .11. These two networks could be summarized as 192.168.10.0/23. Now, that would be what we call super netting, because we had two networks that were what we call contiguous. And when we want to combine two networks together that are contiguous, instead of borrowing left to right, okay, in our network, we actually go right to left. So in this case here, you could have a /23, and then your subnet mask is now 255.255.254.0. Okay. Once again, you would still subtract 255.255.254.0 from all 255s, in which case your resulting wildcard mask would be 0.0.1.255. But super netting can get a little bit tricky. We mentioned it earlier, but we typically don't work with it all that often. Okay, unless of course you're going to be working. Excuse me. Unless you're going to be working in your ACLs like we are here today. Another example, in which you need an ACL number to match networks in the range of 192.168.0 to /24 all the way to 31. The network range would be summarized as a /20, which is a subnet mask of 240. Therefore, because of 255 to 240, so you've got a number of contiguous networks. You have 16 of those networks. 2 to the 4th is 16. We come back the other direction, 255.255.240.0, and which gives me a wildcard mask of 0.0.15.255. If I want to just make my life a little bit easier, instead of always having to write out the wildcard mask, so if I want to do a host, which is a 0.0.0.0, I could just say host, okay, permit host 192.168.10.11, and that host is allowed to come through, or deny host 192.168.1.11. Okay. I could also use the keyword of any. This will substitute for all 255s in the mask. So in this mask, it would say ignore the entire IPv4 address, or to accept any of those IPv4 addresses. An example there would be access list 10 permit 192.168.10.10 space 0.0.0.0. Okay, there I could use host. Okay. Or I could say access list permit, access 11 permit 0.0.0 space 255, 255, 255, 255. Okay. That would be the equivalent of using permit anybody to come through. So now if we look at some guidelines for the ACL creations themselves, okay, these are rules that need to be applied when we're doing an ACL, basic rules, okay. So previously we talked about how wildcard masks are used in ACLs. Now we're going to talk about the guidelines for creating an ACL itself, okay. There's a limit on the number of ACLs that can be applied on a router's interface. For example, if it's dual stack, which means I'm doing IPv4 and IPv6, okay, a router interface can have up to 4 access control lists supplied, okay. So typically, you just want to think of it this way, okay, or specifically this way. One ACL per interface, per protocol, per direction. Okay. So, one outbound, one inbound for IPv4 and version 6. So, I can do an ACL going in and going out for IPv4. I can have an ACL on that same port going in and out for IP version 6. Simply, can't get any more simple than that when we're looking at an ACL. Okay. So best practices when we're using an ACL, okay? And it's important that we take great care because one mistake in an ACL could essentially um, stop all traffic from happening, okay? So it use specific care and great care. Mistakes will just bring down your entire network and you might not know why, okay? Or just give you poor network performance because you're instituting so much more overhead. Um, basic guidelines, okay? Base ACLs on the security policies of your company, not your personal preferences of your company, okay? Write out what you want your ACL to do. We call it pseudocode, okay? Write it out. I want an ACL to do this. And you know what? It also helps to make it a description when you're creating your ACL. Right? Use a text editor to create, edit, and save all your ACLs. It's so much easier if you put it all out in Notepad and then copy and paste it right into your router config. It also makes it a lot easier to edit because when we're putting our ACLs into our systems, they go in sequentially. So if you sat there and said, "Oh wait, but I wanted to permit this line, or I permit this PC, or permit this network," and you add it to your ACL, you added it at the bottom. So it might actually never even get to that entry because of where you put it in your order. So always remember that. As I mentioned earlier, document the ACLs with the remark command and test the ACLs on development network before implementing them on the production network. So hey, that's why you've got Packet Tracer. Okay? So we have different types of ACLs. We have standard ACLs and we have extended ACLs. Now these are really based on numbers that we have. Okay, so a standard ACL or type of ACL here, a standard ACL is it only looks at the source, that is source IPv4 address. You write a permit or deny statement. They're super simple. Then an extended ACL, these permit or deny packets are based on the source IPv4 and the destination, and they can also take a look at the TCP or UDP packet, meaning is it an FTP? Are we blocking web traffic? Are we going to block email? That is all listed in here for you to work with. Okay, so you can have an access list 10 permit 192.168.10.0 space 0.0.0.255, which means I'm going to block the 10. Network. That would be an example of a standard ACL. Now, a standard ACL, another way to look at it is the number that we assigned it. So if we went with access-list 1 standard ACL, access list 10 standard ACL, access 11 standard ACL. Right? But then if we were to jump down and say access list 100, that means it's going to be an extended ACL. Extended ACLs, okay, from 100 to 199 allow us to do source, destination, and choose what ports or protocols we're going to be using as well. So if we were to take a look, okay, what we're looking at down here, this, okay, is an example of an extended ACL. Then this is a named ACL, okay, but named ACLs are also extended ACLs. And this one here, as you can see, is saying I want to permit protocol TCP/IP, the 192.168.10 network, okay, and it's okay, and it's wildcard subnet mask. So I'm looking for this, ignoring this guy here, and to go anywhere. Okay, so stop. So I'm permitting this network to go anywhere to use the FTP protocol. You would want to do that one twice because remember there's port 20 and port 21 FTP and FTP data. Named ACLs is a preferred method when using or when you're configuring ACL, specifically standard and extended ACLs. They can be named to provide information about the purpose of the ACL. So rather than doing a remark, you could just say extended FTP filter, right? So, for example, this filter is a far better way of having a numbered ACL, right? So the IP Access Global Command, okay, Global Config Command is used to create a named ACL. When you do IP Access List, okay, you had to say standard or extended, so you said extended FTP filter. Okay, you want to assign a name to identify the purpose of the ACL. The name will contain alphanumeric characters. They cannot contain spaces or punctuation. And it's also suggested the name be written in all capital letters. It makes it easier, makes it stand out, makes it pop. And entries can be added or deleted within the ACL. That's a nice thing also about named ACLs. And a named ACL, you can go back and edit it. And actually, so, remember before when it said 10, 20, 30, 40, when we looked at the ACLs, we could actually go in and say, oh, I want something in here. You could actually put something in at 5, something at 15. Then it comes down to where do we place it? Well, we saw in our demonstration that we placed the ACLs on the interface using the access-group command. Simple rules. Extended ACLs are typically placed as close to the source, okay, as possible. Because this way here, we're kind of like limiting the amount of overhead that the router has to do as it's processing packets going across router to router to router. And standard ACLs should be set as close to the destination as possible. So the factors that are going to influence where we want to put our ACL the placement can depend on whether or not the organization has control of both source and destination networks. That's an important one. If we think about it, when we're trying to put ACLs on our corporate network, you don't have control of your ISP's network, so obviously you can't put an ACL on their router to block or permit, but you can put it on the end of yours. Okay? You want to look at bandwidth, okay? It may be desirable to filter unwanted traffic at the source to prevent transmission of consuming all of your company's bandwidth. And sometimes it's just easier to put an ACL at the destination, even though it might restrict your bandwidth. Okay, an extended ACL can be used on each router where the traffic originated. It would save bandwidth by filtering the traffic at the source, but it would also require creating extended ACLs on other routers. So here, the administrator wanted to prevent traffic originating in the 10.network network over here from reaching the 30 network, which is over here. And this is our original scheme that we have. But if you remember, we blocked everything from right here. 10.network network wasn't allowed to talk to anybody, right? Wasn't allowed to leave, so we put it right here on the S10. And this, I guess, if you remember correctly, it was actually S00 in our packet tracer. But you can see here what we're doing, okay, is we are placing our ACL to filter traffic, okay, and remember we want our extended ACL, okay, or our standard ACLs to be as close to the destination as possible. So this is my 30 network, so I'm going to put it right here coming out of this interface. So traffic from the 10 network only to the 30, okay? I don't want to put it here coming in, okay? I want to put it here, okay, coming out. Another example, two possible interfaces on R3 to apply a standard ACL. Okay. The standard ACL can be applied inbound on the S11 interface to deny traffic from the 10 network. However, that would also keep us from getting traffic to 31 if we applied it there. So obviously here would have been our best spot, okay? And then on the R3, okay, outbound, the standard ACL can be applied outbound on R3 interface. It will not affect other networks that are reachable by R3. Packets from the .10 network will be able to reach the 31 network, okay? This is the best interface to place a standard ACL to meet traffic requirements based on what you're trying to do here. When we're looking at placing an extended ACL, however, remember, if we remember correctly, I said the extended ACL should be located as close to the source as possible. It prevents unwanted traffic from being sent across multiple networks, only to be denied when it reaches its destination. However, the organization can only place ACL on devices that they control. Therefore, an extended ACL placement must be determined in the context of where the organizational control would extend. So in this figure, Company A wants to deny Telnet and FTP to Company B's 30 network. Okay, so here's my 30 network, and I want to deny all Telnet traffic and FTP traffic to here. So you can see, okay, and then it's from the 11 network here, okay, while permitting everything else. So basically, the easiest way to do it is say, on this guy here, examining traffic from the 11 network, okay, I want it going into my router. And I can just say, all right, everything coming in on this interface, if it's FTP or Telnet going to the 30 network, kill it. Discard the packets. It's the easiest way to set that one up. So that right there, okay, is what ACLs are and how they work. The next video I'm going to create for you would be ACLs for IPv4, how to create an ACL in IPv4.